All right. So A and B are going to be two events, and they give us the probability of A being 36%, the probability of B being 15%. Determine the probability of A or B, given that A and B are mutually exclusive. And then we have A or B, given that they are independent. Now, we've actually already did the independent one. We're adding in the mutually exclusive. If they're mutually exclusive, they don't have anything in common. So when we do mutually exclusive, all we're going to do is the A plus the B. We don't have to subtract the AND because there's nothing in the AND section. So if they're mutually exclusive, you're just going to take the probability of A plus the probability of B. So for part A here, the probability of A is 0.36, the probability of B is 0.15, and so if I add those two things together, I'm going to get 0.51. Now the independent is what we just got done doing, only we did it in 2 steps. So we said if it's an independent event, they can have things that overlap. So you're going to take the probability of A plus the probability of B, and you're going to subtract the probability of A and B. In order to find the probability of A and B, we multiplied those two together, right? We just did it in 2 steps last time. So on this one, for part B, we're going to take the 0.36 plus the 0.15, but we're going to subtract 0.36 times 0.15. I'm going to make it an X times. And so on the previous ones, we did that in 2 steps. We figured out the second part, and then we did the part B part. Okay. 0.456. So you want to have all of your chapter 1, all your chapter 2, all your chapter 3, and all of your chapter 4 turned in for next week when we do the midterm, because I don't want to have to put zeros in for all those grades. Your midterm grade wouldn't look very good if I put zeros in for all that stuff. Number 5 then, same kind of thing. First one is just going to be the mutually exclusive where they don't have anything in common. So I'm just going to take the probability of A plus the probability of B. So I'm going to have 0.47 plus 0.48. 0.95. The next ones, they call them independent events, but really that means that you can have 2 cases that do have something in common. So we're going to take the probability of A plus the probability of B, and then we're going to subtract the probability of both of them happening, which you take A times B. So it's going to look something sort of like that. And we're not rounding our responses, so you'll just carry it all the way out to how many ever places it shows you. 0.7244 is what you should get, yep. All right. Number 6 then, same kind of thing, but be careful. You notice on this one, they ask for the independent one first. They switched them around on you. So if I'm going to find the probability of A or B and they're independent, meaning they have something in common, how am I going to do that? probability of A plus the probability of B minus the probability that both of them happen. So I have to multiply those together. So we get 0.3948. Part B, this time they are mutually exclusive, meaning they don't have anything in common that we have to subtract off on the end. So we're just going to do our 0.32 plus our 0.11, right? 0.43. Okay. So independent means I have two things that could have something in common where they overlap, and I have to subtract off that probability. Mutually exclusive, they don't have anything in common. They're not going to overlap each other.